Hi, and welcome back to the Save It for Parts channel. I've done quite a few videos on receiving L-band weather satellite transmissions from the NOAA weather satellites, the Russian meteor satellites, and some geostationary orbit satellites. And while I've used a variety of antennas to do this, everything from TV satellite dishes to surplus satellite dishes to umbrellas coated in tinfoil, not all of those antennas are easy or cheap for folks to get their hands on, and a lot of them are big, clunky, and take up a lot of space. Now, what if you could 3D print a small, portable, convenient satellite antenna that you can use on L-band? Well, there's a fellow online going by Tonito who has come up with a design for something just like that. I've been wanting to try out Tonito's design for a while. It looks really promising, and I would like to do some other things with this design if it works. First off, I had to 3D print it, so I downloaded the file from Thingiverse. I will throw links down in the description below. So I'm having ongoing issues printing the main part of this antenna, the helical scaffold or support. These three towers just start to bend apart as the print progresses upward. All right, well, another day, more spaghetti. I don't know, these darn 3D printers, they're supposed to be such a time saver, such a great rapid prototyping thing, and I just waste more time than I save with these. I could make this out of popsicle sticks in 5 minutes, and instead I've spent all week to just make infinite trash here and waste plastic. I suck at CAD too much to design this from scratch, so I just took 2 copies of the helical mount, pasted one over the top in the Creality slicer, and moved it down a little bit, and then made sure to line up all these little alignment holes. So now we have basically the same model with twice as many of these horizontal supports. Okay, well, this seems to be working so far. We've got our first 2 supports. All right, looks like it worked. No spaghetti this time. All right, so we've got our pile of 3D printed parts. We've got our instruction manual. So I also need some sheet metal to go inside this ring and some copper wire to wind around my helix here. And wouldn't you know it, you can find nice thin sheet metal just stuck to fences in abandoned buildings. And sometimes inside the abandoned buildings, you can find nice copper wire like this. All right, I'm just kidding. I got these at a garage sale. Stealing is wrong. Trespassing is fun. I mean wrong. I'm probably ruining my scissors here, but it's probably worth it. We need to stick our sheet metal in the middle of this part and drill some holes for these mounting brackets. I also need an antenna connector. I'm going to go with an SMA mount because that is very common for SDR stuff. I screwed my SMA connector into the center of the metal here. Next, we want to coil up this wire so that it matches the coils in our scaffolding here. And you can print out a coiling tool for that, but I found that just a piece of 2-inch pipe works pretty well. Then I just wind my big copper spring into the scaffolding here. You just line up each piece with these offset holes along the way. Once it's all in there, we throw it on the ground. Once the wire's all coiled in there, I cut off the extra and I bent this first piece into the center, onto the center pin of the SMA connector. Well, so far this is looking just like other helical feeds that I've made, with one major exception. This is right-hand polarized, so the coil goes up to the right, or goes down coiling to the right, versus a lot of the helical feeds I've made in the past are left-hand polarized. When you're using a reflector dish, if you're reflecting off a satellite dish and then to the feed, you want a left-hand polarization because the satellite signal is coming down in right-hand polarization, and bouncing it off the dish flips that around. If you're aiming this directly at the satellite, you want the same polarization as the original signal, and for most of the L-band stuff that I'm looking at, that's a right-hand polarization, so it's a right-hand twist on the spiral. Now, I'm supposed to drill and screw all these little pieces together, but I don't actually have these 2mm screws, and I'm kind of lazy, so I think I'm just going to glue everything. Since my 3D printer isn't 100% accurate, I'm having to file down some of these edges to get all the pieces to fit together. All right, we've got this nice big subwoofer looking thing. Everything's glued together. I'm considering actually plastic welding some of these joints instead of screwing them because I have a soldering iron and I can just melt all the joints together, and that way I save on screws. Anyway, the next step here is we need some mosquito net or window screen. So I found some metal window screen and cut out a circle of about the suggested dimensions. Can always trim off any excess later. The hot glue is definitely coming in handy here to tack everything down as I go. Is this the wrong way to do it? Probably. Is it an easy way to do it? Yeah, that seems pretty easy. All right, well, that looks pretty nice. Yeah, the instructions were easy to follow. This was relatively easy to put together. I really like Tonito's design here. And honestly, I think the hot glue made it go a lot faster than putting a bunch of screws in. Now, this is supposed to have a 3D printed handle on the back for hand aiming it, and I left that off for now because I'm eventually going to be attaching this to a satellite dish positioner or motorized mount. For now, I might just hot glue that piece of spare pipe on here to act as a handle, and then I can put the amplifier, the Sawbird LNA, inside that handle to protect it. All right, I gave the helicone antenna a try, and I think it's working pretty well. And here are some of the images we got. It was nighttime, so the daytime false color images don't really work, but we've got some good nighttime microphysics, some infrared, thermal, things of that nature. It's winter here, so the thermal looks pretty cold, but it's still pretty cool. We can see recognizable features, and we got a good signal pretty far north, pretty far up into Hudson's Bay for coverage on this satellite pass. All right, I've got 3 minutes till this pass starts. I'm trying to remember how the rotor control works. I'm trying to get my phone set up so I can do 2 different recordings here with the helicone and my old system. Not getting my TLE files updated in gpredict, so it doesn't know when the satellite's coming over. I'm a mess as usual. Now I want to plug in my SDR to the phone, but the USB OTG adapter won't fit with the stupid case on here, and the case has the Velcro I need, so you know, we're just gonna make this case better. So I'm getting a pretty good signal handheld on the helicone, but the automatic antenna is refusing to start, so I can't really drop this long enough to mess with the programming on here. I got nothing from the motorized dish that time, but the helicone got a good signal from NOAA 18. Since the rotor isn't working for now, gpredict is misbehaving. I'm just gonna leave this aside. I'm just gonna try a different satellite. We're gonna try one of the European MEDOP satellites, MEDOP C, and see if we can pick it up with the helicone here. This satellite can be trickier to receive and decode, but the helicone did a really good job with it. All right, I think I have the TLE thing fixed. Apparently the source of the TLE files, and those are the files that define the satellite orbits and get updated as the orbits change slightly due to drift and whatever. Anyway, the source of those files changed their file format to address kind of some spamming that people were doing with that download service, and update things with there being so many new satellites, they had to make some new categories. Anyway, we've got gpredict using the new sources. We have downloaded those, we've verified those. I just tried another satellite that I wasn't getting a radio signal from, but just tried to lock onto it to make sure it worked. So I think that works. So I think that our automatic tracking antenna will now successfully track and follow some of these satellites. So we can do a side-by-side comparison between this antenna, which has been my go-to standard for L-band, and the helicone antenna. This is all very hard to do last minute, and I never give myself enough time beforehand to set up. I always think, oh, 10 minutes to set up before the pass is going to be enough. No, it's never enough. All right, so I admit I really screwed up on that last pass. I was not ready with either antenna. I did get both tracking at the same time, but then I realized later that I had the frequency offset slightly wrong on the laptop, so I didn't get as much of the NOAA 18 pass on the laptop. I got more of the pass with the helicone antenna on the phone, but the quality wasn't as good because I was shaking all over the place. I was not a good stable tracking platform. That's the whole idea of this antenna mount, is that it is a stable automatic antenna tracking platform. It doesn't wiggle around, it doesn't get cold fingers, it doesn't get ADHD and jerk around when it sees a squirrel. So this thing is supposed to be a much more reliable directional antenna positioner than I am. This was not a great pass. It was kind of way off to the west, so we got a lot of the California coastline and we didn't get as much of the Midwest, so it was kind of marginal to start with. The next one we have coming up is one of the Russian Meteor satellites. So again, I'm going to try tracking with both antennas. This Pelco pan tilt mount has been honestly working really well for satellite tracking. It's designed for a security camera. It's not designed for this application at all, but I love it, and it's been one of my most reliable satellite trackers. If I could find a really big outdoor heavy-duty Pelco unit, I think I could put a really big dish on it. If you saw my previous video on the discone antenna, that's this thing up here, you might be a little confused by the terminology. Again, this one is a discone. This is a scanner antenna for like UHF to 900 megahertz. And this one is the helicone with the helix and then the cone feed. And that one is for 1700 megahertz. So very similar names, but very different antennas and different applications. Heck, I keep confusing the two words myself on some of the videos. I'll have to go back and edit it out if I said one versus the other. Neighbor's cat Oliver is in the garage again, and he's being a jerk. He won't even say hi to me. Hey, yeah, hello. Hello, you're so rude. I'm glad I finally put in the one-way cat door, so now when he gets himself stuck in here, he can at least leave. I still want to hand track this pass of Meteor M24, but since Stellarium has decided that it doesn't exist, I'll have to use gpredict and just follow where this dish is pointing with my other dish. We'll see if that works at all. Alright, we're running that recording through SatDump to decode it, and it looks like we got a pretty good signal for most of the pass. Alright, it took all day, it took a lot of false starts, as usual with my satellite projects, but we finally got a good side-by-side comparison between the helicone antenna and my existing dish-style tracking antenna. So let's take a look. Here is what we got from the helicone antenna through the RTL-SDR on my phone. And again, remember, I had lost my Stellarium tracking here, so I was tracking just by seeing where the other dish was aiming. I think I still got a pretty good signal. I've got a nice clear image from when the satellite was pretty much right overhead. And then we do start to lose some data. We start to get some lines of errors and whatnot as the satellite goes north. But still, this is pretty decent. And we got coverage for a pretty wide geographic area from south to north. I think that's very acceptable. As usual, we've got imagery in various spectrums, so some thermal stuff, some infrared stuff, false color overlays, all the usual stuff that SatDump outputs from Meteor M2 data. Some of these instruments are designed to look at different cloud layers, some of them are designed to look at surface temperature, and they all do slightly different things. So let's see what we got from the exact same pass with the automatic tracking antenna. And this looks really similar. I would say there are fewer errors as we go north. We have fewer dropped lines of data, although we do have dropped lines in exactly the same place that I got drops with the handheld helicone antenna. So overall, they're very, very similar. The automatic tracking dish, the quality of the image looks about the same. The geographic coverage looks about the same. I think that both of these antennas performed in a very, very similar manner. And really the only difference is that my handheld aiming is not quite as good as the computer control. So in conclusion, what do I think of Tonito's helicone L-band design? I think it's fantastic. This thing is much better than any of my other antennas as far as size, weight, ease of use. I can wave this around, I can lock right on to a satellite one-handed. I don't have to juggle some giant dish over my head. I don't have to balance something on a tripod and try to get it aligned just right. Now, to make it even better, I do want to make it computer controlled. So that is going to be the next video. I'm going to take the helicone antenna here and I'm going to try smashing it into one of my portable RV satellite domes. This is a Winegard carryout. That's going to involve a lot of programming, a lot of swearing at Python, and probably a lot of false starts as usual. So we'll make that a different video. If you'd like to try out this design for yourself, I will put links down below to Tonito's original files, to the instructions, all that stuff on Thingiverse. And then I will also include links to the electronics that you'll need. The amplifier LNA that I put in the handle here, the RTL-SDR software-defined radio that I use for a lot of my projects. And those are basically the only electronics you need other than a laptop or a phone, an antenna wire, and then just need a little bit of copper wire for your center feed here. And again, I have not used any screws in this other than a couple bolts to hold the helix onto the cone. The rest of this I just hot glued, and then I did go back later with a soldering iron and just basically weld all the joints together. So that gives it a little extra strength and extra stability, but Otherwise, there's no fasteners in it. I think Tonito did a great job designing this. It's really cool. If you have a 3D printer, download this file, print the thing out, play around with it. It is a fantastic antenna design. For now, that is all I have for this video. You can check out my past videos for how I built that DIY tracking antenna, and of course, stay tuned for the future videos where I expand on this topic. You can always like and subscribe so you don't miss those. Thank you to everyone for watching, and we'll see you next time.